Welcome everybody to our first chemistry video for this year. You're going to have to bear with me just a little bit because I'm trying to figure out how to use this document camera to record videos. It's a first for me, but it's a first for all of us, so hopefully we'll get better throughout the semester. But I'm going to be posting all of my videos to YouTube so that when I post them to eClass, they're links to YouTube. So if you'd like to see them immediately once I post them, towards the end of the week, you can subscribe to my YouTube channel, and there you'll have it. Alright, so today we're going to be talking about converting units. And this is something very, very important for science, and the other thing we'll talk about a little bit is rounding for significant figures. We're going to be doing both of these things throughout the entire year, because in science, whenever we measure or calculate anything, those values mean something. They mean how much something weighs, or the temperature, or how big something is, or the volume it takes up. All these different things have units associated with them, and if you do not tell somebody the unit, they don't know what you're talking about. So sometimes we need to change units to make the number look more meaningful or to be able to calculate appropriately, and that's what we're going to cover today. So let's get started with the basics of unit conversions. Okay, so it keeps doing this thing. I can't get the blue box to go away, but that's okay. Alright, so unit conversions. So unit conversions are only possible if we know the relationship between the two units. And so in this case, I'm going to fill in, and basically if I'm writing something in one of these videos, it's probably a good idea to add it to your notes. So I went ahead and left some blanks so I can kind of write as we go and talk through each of these things. So a unit, or the measurement that tells you how much of something you're using, can be converted if you know the relationship between the two units. And so how is one unit compared to another unit in size? How many of them are there in the other unit? Okay, so this example is going to help to illustrate what this sentence means. So if we wanted to convert 29 minutes to seconds, the units we're taking are minutes and seconds. Okay, these are units of time, so they tell you how big of a chunk of time has passed. Alright, so the relationship between them is what we need to be able to convert. How many seconds are in a minute, or how many minutes are in 1 second? We know that seconds are tinier, and there are a lot of them in a minute. There are 60 of them in a minute. So that means that the relationship is that 1 minute has 60 seconds. Since this is the amount that is in 1 minute, they're both talking about time, that means that these two things are equal to each other, which might sound strange because the number here is 1 and the number here is 60. But that's the beauty of units. They allow us to have equal things even if the numbers are different. 1 minute is 60 seconds. They are equal. Okay, once we have that relationship, we can take it and turn it into conversion factors. These are things that you need in order to actually perform your conversion, unit conversion. So to make a conversion factor, we set it up like a fraction, and we take the two things from our relationship to make that fraction. So we can take 1 minute and we can put it over 60 seconds in a fraction, or we can do the opposite, 60 seconds on the top, 1 minute on the bottom. So I'll write that out. Okay. Now some of this might be review for you guys, but I just want to explain in a very simplified way how I think about converting units. So whenever I'm doing this in class with you guys, you know what I'm talking about. Alright, so when we want to convert, we're going to take our given, which the given was given to us in the problem, our 29 minutes. That's our given. We want to convert that. So we're going to take that we're going to multiply it by a conversion factor. Remember, we just wrote out two different conversion factors, so we have to figure out which one. Okay? So I'm going to write it out one way first. We've got 29 minutes. We are going to multiply it, like it says here, given times. Conversion factors are fractions, so I'm going to draw a line for my fraction. Alright, so if I try the first one here, 1 minute over 60 seconds. What happens when I multiply here? I get 29 times 1 divided by 60 if I just do my numbers, but we want to pay attention to our units. Minutes times minutes. Something times itself. What does that give you? That gives you that thing squared. So we would get minutes squared over seconds as the unit in the denominator. And here I just kind of ignored the numbers so that we could look at the units. Now, we were trying to convert to seconds, right? We weren't trying to convert to minutes squared over seconds. So this is not going to be the way to do it. That means that's the wrong unit conversion. The wrong conversion factor. So that means we're going to choose the other one. So 29 minutes times 60 seconds over 1 minute. And then when we look at this, minutes times seconds, that's fine. Minutes divided by minutes. Something divided by itself is equal to 1, and so therefore it's not important in the calculation. That means it cancels out. So if you have a unit in the numerator somewhere, which a number by itself is a numerator, and the same unit in the denominator somewhere, they're going to cancel. This is basically something divided by itself. So minutes cancels, and we're left with 29 times 60 seconds over 1. So I'm going to write that out in one big fraction. 29 times 60 seconds over 1. Remember, if you divide by 1, that's not going to change the number at the top, so it doesn't really matter. We can just get rid of that 1. We get 29 times 60 seconds. Okay, so remember, this canceled. And this, divide by 1, nothing happens. Sorry, went off the screen there. Alright, now, when we do 29 times 60 seconds, we end up with 1740 seconds. If you had a calculator, you could have seen that. Okay, so now, just like we wanted, our ending unit is seconds. Our number has now changed because we converted the unit, and there are 60 seconds in every single minute. So if we have 29 minutes, we should have way more seconds than the number of minutes. That's the relationship between seconds and minutes. Okay. Alright, now we're going to move on to some other metric relationships, or some metric relationships, because those are super common in chemistry. And one that you're going to see all the time is grams. Okay, so these are the relationships between different metric sizes of gram-based units. 1 gram, which is probably about the size of a pack of sugar, if you're or weighs about as much as a pack of sugar. 1 gram is equal to 1,000 milligrams, and that's because milli means 1,000th of a gram. So if you have 1,000th of a gram, you're going to need 1,000 of them to make up 1 gram. Okay, so that's their relationship. Milligrams are really, really tiny. Okay, you might see this a lot of times on pill bottles, because a lot of times medicines are given in doses of milligrams because our bodies don't need a large amount. Usually it's a really tiny amount for whatever protein or enzyme. Alright, now if we want to think about kilograms, if you go to the store and were to buy big bags of flour or something like that, a lot of times the mass you would see if it was given in metric units would be kilograms. And in a lot of countries, when they tell you how much they weigh, they'll tell you in kilograms because they use the metric system, and we in America are strange and we don't like the metric system for normal everyday things. Okay, but kilograms are pretty big units. So if you think about your little pack of sugar, you need a whole bunch of packs of sugar to equal the mass of a kilogram. So 1,000 grams will be equal to a kilogram, and the abbreviation for that is kg. And then we get down to micrograms. You might think micro. That means really tiny, like a microscope sees really tiny things. So remember, if it's micro, it's teeny tiny. It's 1,000 times smaller than a milligram, which we already said a milligram was really small. So a microgram, you need 1,000 of them to make up 1 milligram. All right, now we have those relationships. So we're going to do an example of converting here. We want to take 57 grams and we want to convert it to milligrams. Let's remember our relationship. Our relationship was that 1 gram is equal to 1,000 milligrams. So for this, we have 1 gram equals 1,000 mg. Now we can turn that into some conversion factors. I hope I don't run out of room here. All right, so for our conversion factors, remember we can take one piece and put it over the other one in a fraction. So 1 gram over 1,000 grams. Oop, milligrams. Look at me with my units messing it up. Okay, or we can take 1,000 milligrams and put it over 1 gram. Okay, those are our 2 possible conversion factors. Now we're going to choose the one that will allow our 57 grams, our given unit, to go away. So our given unit is grams. We want grams to cancel. Remember, we got to divide grams by itself. So we need the conversion factor that has grams in the denominator. And sorry, I know I wrote that really ugly. This one, I'm just going to write it below. It says milligrams. Okay. This one has grams in the bottom. So that's what we're going to need in order to convert 57 grams. So let's do that. I'm going to draw a line here so we can separate it out. 57 grams are given. Remember, we take our given times our conversion factor times, we're choosing this one. 1,000 milligrams over 1 gram. So here we go. Grams cancels because we have grams from our given divided by grams in our conversion factor we chose. That means we have 57 times 1,000 milligrams over 1 gram. Remember, dividing by 1, nothing happens. So I'm just going to skip a step. Hopefully nobody gets confused, but if you do, ask me a question. And I'm just going to write 57. Oops, the grams is now gone, so I'm going to write times 1,000 milligrams. So if you think about it, 57 times 1,000 should give you 57,000 milligrams. And that would be the answer for that first example there. Now let's move along. This is a little bit of a step up in complexity. And I'm not going to be able to finish it in this video, but I want you to try to figure out before you look at the next video what relationships will get us from grams to micrograms. And here's a hint. You're going to need 2 different relationships from up above. So I'll show you real quick. Remember, we're going grams to micrograms. That little symbol right there means micro. Okay, so let's look up here. What 2 relationships could get us from grams to micrograms? I want you to think about that before we get to the next video.